Now second application is priority queue implementation. Now priority queue if you see in operating system, तो दो तीन इसमें सिर्फ चार फंक्शन, जैसे हमने पिछले एग्जांपल में किया था बिल्ड हीप फंक्शन। बिल्ड हीप क्या कर रहा था, इन सिर्फ n/2 से लेके 0 तक एलिमेंट्स को के लिए मैक्स cp5 फंक्शन कॉल करता था। तो इसमें मैक्स cp5 फंक्शन है और बिल्ड हीप फंक्शन जिसको हम जनरली बुक्स में देखा जाता है। प्रायोरिटी क्यू के अंदर क्या होता है, आई एम अज्यूमिंग दैट माय मैक्सिमम वैल्यू इज द हाईएस्ट प्रायोरिटी। दैट मीन्स जिसकी वैल्यू मैक्सिमम होगी वो हाईएस्ट प्रायोरिटी होगी, जिसकी वैल्यू कम होगी प्रोसेस की वो लीस्ट प्रायोरिटी होगी। तो मैं प्रायोरिटी क्यू इम्प्लीमेंटेशन में ये भी ध्यान में रखना, जब जिस पूल में उस टाइम में जो प्रोसेसेस हैं उसके अकॉर्डिंग ही वो सर्व किए जाएंगे सीपीयू को। लार्जेस्ट प्रायोरिटी का प्रोसेस था लेकिन वो लेट आया था, टाइम के अकॉर्डिंग सीपीयू विल गेटिंग दोज प्रोसेसेस एट दैट मोमेंट ऑफ टाइम जो पूल में है, उसमें से लार्जेस्ट प्रायोरिटी के प्रोसेस ही वो प्रायोरिटी क्यू सिलेक्ट करता है। दैट मींस इट इज ऑफ डायनामिक नेचर, कुछ प्रोसेसेस आ रहे हैं कुछ जा रहे हैं, at that moment whatsoever the value it is getting for that process, highest value, it is picking that only। ठीक है, तो सीक्वेंस मैटर करता है किस सीक्वेंस में ऐड हो रहे हैं, कब ऐड हो रहे हैं। दिस वाज अ फंक्शन टू इंसर्ट, सेट लगा लो, डाटा स्ट्रक्चर सेट लगाते हैं लेकिन इट इज वी आर जस्ट इम्प्लीमेंटिंग इन द फॉर्म ऑफ एरे। तो ये इंसर्शन ऑफ एन एलिमेंट इन द प्रायोरिटी क्यू के लिए इंसर्ट फंक्शन है। ये एक्सट्रैक्ट मैक्स वो रिमूव करता है लार्जेस्ट वैल्यू को, कि एक प्रोसेस बताओ जिसकी लार्जेस्ट वैल्यू सीपीयू को चाहिए, कहते प्रोसेस P3 है, इसकी प्रायोरिटी है से 75, तो इसको वो पूल से निकाल भी देता है और सीपीयू को इसका टेंशन भी देता है। रिमूव एंड रिटर्न्स द एलिमेंट विद द लार्जेस्ट वैल्यू, की वैल्यू। मैक्सिमम इट जस्ट टेल यू व्हाट इज द लार्जेस्ट वैल्यू, कौन सी वैल्यू पूल में अंदर प्रायोरिटी की लार्जेस्ट वैल्यू है। इट डज नॉट एलिमिनेट इट, ये एक्सट्रैक्ट भी कर देता है, ये सिर्फ बताता है कौन सी लार्जेस्ट प्रोसेस वाली कौन सी लार्जेस्ट प्रायोरिटी की वैल्यू का है। इंक्रीज की, यू माइट हैव हर्ड द प्रोसेस ऑफ एजिंग विद इन ऑपरेटिंग सिस्टम। काफी देर से पूल में एक प्रोसेस पड़ा जिसकी प्रायोरिटी पहले 3 थी, तो ऑपरेटिंग सिस्टम क्या करता है, डिपेंडिंग अपॉन दैट द प्रोसेस इज टेकिंग टू लॉन्ग in the ready queue to get served by the CPU, तो आफ्टर सम टाइम क्वांटम वो उसकी प्रोसेस की प्रायोरिटी को बढ़ा देता है ताकि कभी ना कभी वो स्टार्व ना रहे, उसको कभी ना कभी सीपीयू की टेंशन मिले जरूर। दैट मीन्स वी आर इंक्रीजिंग द, बिकॉज वी आर सेइंग इंक्रीज्ड प्रायोरिटी is beneficial in terms of less priority, so here we are saying we are increasing the value of the key element to k। they operating system करता है time to time, so this functionality increases the heap maximum function। we want to find the maximum value without removing the same from the heap data structure or a priority queue। So what to do in this case, they just want to know which process in the operating system has got highest priority, so how to retrieve that, if it's the max heap, that maximum, if we are dealing with the maximum priority, so maximum in max heap the maximum priority will be residing at the root of the heap tree। Similarly, if you are using min heap for priority queue implementation, min heap means that minimum value of will be taken as the highest priority. Even in that case, root element, that is A0, will be storing the element with the minimum value, that is the highest priority. So this function operation takes order of 1 time in either case. That means in either case you will be returning starting root element, that element at index 0. Next function is heap extract max. That means extracting the maximum value from the max heap operation. That is max heap tree. Now in max heap tree, the largest element resides at the root. So that the largest value, this is a priority queue implementation where maximum value reflects highest priority. So if you want to extract the largest element with largest priority, then this is different from the maximum function where you just want to print that maximum value or maximum priority value without removing it. This will allow you to remove the element also. Now what to do? Just replace the first last element with the root element and store this root element and return this root element back to the calling function. When you are replacing this with the last element, then reheapify or max heapify this function at the root node only. That means you have to apply this max heapify function only at for once, that too at index 0. So what is the basic operation inside this? That means if I want to extract maximum value from this priority queue, that means we want to retrieve give a process with highest priority to the compute process CPU. Then the highest priority process will be residing at the root. This will be stored in some integer variable. Now this will be this maximum root value will be replaced by the last value in the heap. After this last value is being copied to the root at the place of A0, then heap size is reduced by 1. That means the number of elements have been reduced by 1. Then we have to call max heapify operation at the index 0 in the array A. So max heapify will do what? This will settle down the this new element which has been placed at the root position at proper position. Like we are dealing with max heapify function. So in max heapify function, what will happen? This value will be compared by its children node. As you can see, children node, this left child is greater than right child. So this will be swapped with, one will be swapped with the left child. Similarly, one will come here, then one will be compared with 8 and 7. 8 is largest, so 8 will come here. Again, one will be compared with 2 and 4. 4 is largest among 2 and 4. So one will come here and 4 will go there. So in this sense, you will be getting, after max heap, if I add 0 index, you will be getting this final heap tree, which is a max heap tree now. Now this is the algorithm for the same. If heap size is less than 1, no need to apply, you can't extract any element because number of elements are already equal to 0. Otherwise, retrieve the maximum element in a variable max and copy in the A0 index the last element of the array and decrease the heap size by 1 unit. Apply max heapify on the 0 index and at last return the maximum element which has been removed from the heap. As you know, the remaining set of these operations takes constant amount of time, this and this also. And max heapify function takes log of n time, log to the base 2n time. That is why this heap extract max function takes log to the base 2 of n times in the overall scenario. Next is heap increase key. Now heap increase key does what? Just like we have done in aging, if the process takes too long in the pool, waiting for the turn by the processor, then its priority is, let us suppose we are saying dealing with max value as maximum priority, so its priority after some time quantum is being increased to some value. This is called increase the key value of the within the priority queue. So how to get it done? Like if you want to increase the key value of, say, this element which was earlier priority queue is 4, but we want to increase it to 15. So we will have how to apply heap increase key. Now after updation of this value, compare this new value with its parent node. Now we are dealing with max heap operation. So in max heap, this value is already, this child node is smaller than its parent. This will be swapped, 8 will come here, 15 will come here. Now 15 will be further compared with 14. 15 will come here, 14 will go here. 15 is further compared with 16. So 16 will, this is the proper place of 15 to settle down. That means every time that new updated key value is being compared by the parent till it gets settled at a proper position, or in some case this too can happen that, for example, if we are, rather than updating the value of key which was earlier value of process priority value as 4, now let it be 25. In that case 25, how to settle on 25, it is compared with the parent key. Parent key is larger, then what to do? 25 will come here, 8 will go in this direction. 25 and 14 are further being compared, then 25 will come here, 14 will go in this side. Then 25 will be compared with 16. Still your 16 is less than 25, then 16 will come here, 25 will go here. Now you can't find the parent of 25 because 25 is already the last node or the root node. Then that means that your process will start comparing the element with the parent node till you are reaching at the root node. That means no parent is left further, or in other case your element settle down at the proper position, maintaining the property of max heap. Now let us take the example. Now 15 is being there, 15 is being swapped with 8. This 8, 15 and 8 are compared. Again find the process parent, then node parent, then 14 and 15 are being swapped. No further swap is being possible because 16 is already larger than that of 15. So increase key function is we have to find the parent of that. Till parent is less than that of AI, we have to traverse, or I greater than 0. That means we don't reach till root node. Once you get at the root node, we will have to come, this loop will become false, and you will have to come in either of these conditions. You will come out from that loop, while loop. So you will exchange ai and a parent of I, and next time I will become equal to parent of I. This loop will be executed, and exchange of values will be done until your final element with new key value it settles down. The whole of the operation takes log of the 2n time, because at the most you will be traversing this tree structure, because this is a complete binary tree. So you will be traversing this, and height of this complete binary tree log to the base 2n. The maximum complexity of this heap increase key function is also log to the base 2 of n time. Now next comes max heap insert. Now max heap extract means you, if you want to remove the element from the priority queue. Max increase key means if you want to update any process priority value. Max heap insert is insertion in the priority queue. Now what to do? The direct method for insertion in priority queue is, whenever you want to perform insertion, you know always new element is inserted at the last of the array. So let us assume you are inserting any sentinel value. If you are dealing with max heap, that sentinel value will be minus infinity. If you are dealing with min heap operation, that means minimum value is taken as highest priority. In that case, you will be taking help of plus infinity for the same. Here in this example, we are dealing with max heap. That means maximum value reflecting maximum priority. So we are saying that some minus infinity, many very small value, has a process with very small value is being inserted into the priority queue. Now this is a sentinel value minus infinity we are adding. After that, actually we want to add a process with priority say 15. So what to do? First we are adding some sentinel value process minus infinity. Then we will, what we are saying, we are hypothetically saying that we are applying a increase key function. That means earlier the process was having minus infinity priority value. Now the process priority is 15. That means there is an increase in the process priority. Apply increase key function for the same to settle down the element at its proper position, obeying the property of maxi. So the same thing has happened. Minus infinity, apply the heap increase key function as we did in the previous slides. So 15 will get settled on proper position. How 15 will be compared with its parent node. 15 will come here, 7 will go in this direction, then 15 and 14 will be compared. 15 will come in this side and 14 will go in this direction. Accordingly, this will be the final tree after heap increase key function has been invoked. So this is the algorithm for the heap key, that whenever you are inserting a new element, obviously heap size is increased by 1. And in the last index, what you have to do, you have to apply, add minus infinity inside that, and then apply heap increase key function accordingly. Okay, next is just make one correction, because heap size here will be the, if you're going from programming point of view, heap size will, if the number of elements, that will be equal number of elements. So last index of heap size, it should not be incremented. We can directly apply, because if the heap size is equal to n, so last index element of will be n minus 1. Earlier it was n minus 1. If you are applying, adding a new, this will be the, let us suppose it's the heap size. So then you will adding a new element at an location. So no need to apply this algorithm, this syntax, if you are implementing the same from programming point of view. You can directly write a of heap size is equal to minus infinity, and thereon you can increase the, after that you can increase the heap size is equal to heap size plus 1. So you have to swap these two instructions position. This will be number 1, this will be number 2. Accordingly, you apply remaining heap increase key function accordingly. Now, this is the example, create max heap using priority implementation, how to apply. First 5 is inserted, after 5, 3 is inserted. How to insert 3? Replace it by minus infinity, apply, then when you are applying increase key function, you will be replacing by 3. 3 and 5 will be compared, then because in max heap, no change. Then 17 is being inserted, 17 is inserted somewhat here. 17 and 5 are compared, so 5 will go downward, 17 will go in this direction, then 10 is being inserted. When you are inserting 10, 10 will sit somewhat here. 3 and 10 are being swapped out. 3 and 10, this is the final position of the 10 to settle down. Then 84 is inserted, 84 will be inserted somewhat here because it is not a proper position according to max heap property. So 10 will come here, 84 will go here, 84 and then 17 will come here, it will come here and 17 will go there. This is the answer of after insertion of 84. Similarly, when your 19 is being inserted, 19 will be inserted, insert 19, the 19 will be inserted somewhat at the left side of this according to the notation. So 19 and 5 will be compared, 5 will come here, 19 will settle down here because 84 is less than greater than 90, so 90 will settle down accordingly. Similarly, insertion of 6 according to notation will settle down here. 6 and 19 are compared, no change in the further in the tree structure. Then 22 inserted, 22 should be inserted somewhat here. 22 and 3 are compared, 3 will come here, 22 will go here, 22 and 17 are we compare, 17 will come here, 22 will go here, and accordingly your insertion has been performed. Then insertion of 9, when you are inserting 9 at that position, 9 will be inserted somewhat here. According to notation, 9 and 17 are compared, no change in the position of the final tree structure. So this is the output after insertion of the all the elements using max heap insert function. So this will be final, the array will be 0, 1, 2 index. Accordingly, you can store those elements level wise. This is the final answer according to the in the form of array representation. Now let us take the example. Some question might be written like this: perform the following operation in a given sequence on the in the given array. First is your max heap function. On the given, this is a given max heap is in there. You have to apply heap extract max. That means you have to remove maximum value element from the priority element from the given heap structure. This is a priority queue implementation basically. You represent this array in the form of a tree-like structure, like in the level order wise 20, then 15, then 19, then 9, 14, and so on. You apply heap extract max. So what heap extract max does, it removes the root element and store it in some variable like max and replaces its, in lieu of that, the last element of the array is being placed at the topmost position, that is at A0 index. Now we have to this element A0 which has been settled down from taken from the last index of the array. This disturbs the heap max heap property. So what to do in this case? You will be applying then this will be compared according to max heapify function. This value will be compared with its child node because out of this child node this 19 is larger, so 19 and 11 will be swapped like this. After this, again try to settle down whether 11 has settled down or not. It has settled, still not yet settled down because 11 is smaller than its children node because we are dealing with max heap tree. So this will be largest element will be swapped with that of 11, that is 16. So 16 and 11 will be swapped. This is the final tree which will be created after the first operation, that is heap extract max. Next is max heap insert. That means we want to perform insertion in the priority queue with the value 25. Now how to deal with this? When you are applying within the array, this is the further this array representation of this tree like heap tree structure. So if you are applying max heap insert A25, what will happen? New element will be we are assuming that we have added a minus infinity process with priority value minus infinity, and we are applying a heap increase key function by updating that key value or priority value as 25. So 25 has been replaced by minus infinity. Increase key function will do what? It will start comparing this value with its parent node. So 25 will come at the upper end because it is smaller than its larger than its parent node. 25 will go at this end. 25 and then 16 will be compared. When you're comparing 25 and 16, 16 will go here and 25 will come at this position, just like in this scenario. Then 25 is being compared with 9. It's again for the parent node. 19 will come here, 25 will go at the upper end. So this is the final answer after application of max heap insert operation. In the similar way, you can get many questions in the final